Hello everyone, and welcome. Today, we're going to talk about a simple but super important idea in organic chemistry called heteroatoms. You've probably heard the term, but what does it really mean? Let's break it down. Organic chemistry is often called the chemistry of carbon. Most organic molecules are built from a skeleton of carbon atoms, usually with lots of hydrogen atoms attached. Think of these carbon and hydrogen structures as the basic, plain framework. A heteroatom is simply any atom in an organic molecule that is not carbon or hydrogen. It's like adding a special, unique ingredient to a plain recipe. These special ingredients completely change the properties and behavior of the molecule. The most common heteroatoms you'll see are oxygen, nitrogen, sulfur, and the halogens like chlorine, fluorine, and bromine. So, why are they so important? Well, they do a few key things. First, they introduce polarity. Heteroatoms are usually more electronegative than carbon, which means they pull electrons towards themselves. This creates an uneven sharing of electrons in the chemical bonds, making one end of the bond slightly negative and the other end slightly positive. This polarity makes molecules soluble in polar solvents like water. For example, ethane, which is just carbon and hydrogen, is a gas that doesn't dissolve in water. But ethanol, which has an oxygen heteroatom, is a liquid that mixes perfectly with water. Second, heteroatoms are often the site of chemical reactions. The lone pairs of electrons on atoms like oxygen and nitrogen make them reactive. They can act as bases or nucleophiles, which means they are ready to form new bonds. Essentially, the heteroatom is the hotspot on the molecule where the chemical action happens. They are the heart of what we call functional groups. Third, certain heteroatoms, especially oxygen and nitrogen when bonded to hydrogen, allow for a special type of interaction called hydrogen bonding. This is a strong attraction between molecules that dramatically increases boiling points. It's the reason why water is a liquid at room temperature and not a gas. This same effect explains why alcohols have much higher boiling points than similar-sized alkanes. From the nitrogen atoms in our DNA and proteins to the oxygen in sugars and alcohols, and even the sulfur that gives garlic its distinct smell, heteroatoms are what give organic molecules their diverse functions and characteristics. They truly are the spice of organic chemistry, turning simple hydrocarbon frameworks into the complex and fascinating molecules that make up life and the world around us. Thank you so much for watching. If this explanation helped you understand heteroatoms a little better, please show your support by hitting the like button, subscribing for more chemistry videos, and leaving a comment with any questions you have. Your support is greatly appreciated and helps me continue making these educational videos for everyone. See you in the next one.